So now today's topic is spanning tree, and we will solve one problem by the algorithm of Krushkal algorithm to find out the spanning tree as well as the shortest path. So here you can see a graph A, okay, where 4 nodes is there. So what is spanning tree? A spanning tree of a graph is just a subgraph that contains all the vertices and is a tree. That means all the vertices will be connected with a minimum number of edges. That is called the spanning tree. Uh, so what is the minimum number of edges? So that is depend on the number of if the number of node or the vertices is n. So to connect all the node or the vertices is required n minus 1 number of edges. Okay. So with n minus 1 number of edges of any graph, if there have no closed graph, if the graph is not closed, or if the graph has no loop, so that is what that time we can say that the tree or the graph is a spanning tree. So here the example, that is graph A, where 4 vertices and every vertices is connected with everyone. Suppose this is a vertices that is connected with B, C and D, and same B is connected with A, C and D. So all the vertices is connected with each other. So how many edges here? 1, 2, 3, 4, 5 and 6. So 6 vertices and 6 edges. But if the graph, we make this graph as a spanning tree, so that time how many node should be there?
স্যার একজন ঢুকবে অ্যাকসেপ্ট করুন একজন ঢুকবে
So because of there are 4 vertices, so minimum edge,
স্যার
the minimum number of edge is 4 minus 1, that is 3. Okay. So now you can see for a particular graph there has more than one spanning tree. So here you can see the A, B, C, D all are connected with this is a connected graph. Okay, and you can see C and D is connected with an edge. A and B is connected, and A and B is connected. So all the node is connected. Okay, no extra edge is there. Okay, after the connecting of all the vertices, no extra edge will be required to connect or to close or any loop. Okay, so we have to ignore the extra edges so that we can find out the graph or the tree, that is called spanning tree. Okay, then you can see the figure of different kind of uh, figure or the graph, that is also the example of spanning tree of graph A. Okay, so anybody have any query or any question related this diagram or figure? You can see this is the connection, the reverse connection. Here is the D and D is connected, and here B and C is connected by diagonally, and A and D is connected diagonally. Here A and D is connected diagonally, A and B is directly connected, C and D is directly connected. So all these are the spanning tree. Okay, so next, so you can see some more spanning tree. So all 16 of its spanning tree that is derived from this complete graph. Okay. So however, all the spanning tree, from all the spanning tree, the only thing is that all the vertices is connected, no extra edges is required, no loop is required. Okay, and whatever the figure, whatever the connection, only the rule is, that is n minus 1 number of edge should be there if and only if n is the total number of vertices. Okay, next. So is minimum spanning tree. So minimum spanning tree, a common problem in communication network and circuit design is that of connecting together a set of nodes by network of total minimum length. Okay. So minimum spanning tree is nothing but a tree with a weight. Weight means the edge has a value. Every edge has a value or weight. That is called weight basically. So according to all total the whatever the graph is given, or the from the complete graph, who is the what is the this is the complete graph. From this complete graph, when we derive one spanning tree, that time we have to calculate the minimum weight. We have to check what is the minimum weight of particular edge. The high priority, we have to select those edges, those have minimum weight. So minimum weight, that is the high priority. So by this way we can select those edges only, the edges have minimum weight, that will be selected for spanning tree. Okay, so that time after getting all the minimum weighted edges, when we draw a spanning tree of a particular complete graph, so that is called the minimum spanning tree. Clear? So what is the spanning tree and what is the difference between minimum spanning tree? So any graph with n minus 1 number of edge, the representation of any complete graph with n minus 1 edges is called the spanning tree. Here, that is the minimum number of edge. And now, if there, so for a particular complete graph, there have more than one spanning tree. Okay, so between all the spanning tree, the only one spanning tree who have the minimum weight. Maybe there have more than one different graph or different spanning tree, but both have, or more than one, any more than one spanning tree have the same weight, total weight. So that is also under the minimum spanning tree. Okay. So there is a representation of graph. We know graph is a set of V and E, where V is the set of vertices, E is the set of edges, and here minimum spanning tree that indicates the minimum weight. So finally we have to calculate the weight. W represents the weight of particular tree, that is summation of all the U and V. So here what is U? U is uh, edge, each edge between U and V. Each edge between U and V. U is a, obviously U and V is nothing but two vertices. Between two vertices, the edge have the weight. Okay, and total edge, when we calculate the summation of all the edge, weight of all the edge, that is the total weight of the tree. So this is the rule, and if we get the minimum spanning tree, if we get the minimum value of W of T. Okay. So this is the algorithm. Step 1, that is create the edge table. So what is the age table that will be discussed in the solution of any one problem that will be discussed later? Just think, that is, create the age table. That means we have to create the table with every column have a name of that age, like A to B, A to C, B to D, B to E, this kind of column, and under each column we have to write down the weight. Okay, so this is the basic scenario. So here you can see an age table will have name of all the ages along with their weight in ascending order. That is from smaller weight to bigger weight. Okay. Now look at your graph and calculate the number of ages in your graph, and draw a table according to number of ages. You have to draw the table. Okay. And in our case, our graph contains 13 edges. Whatever in our example, you can find out there have 13 edges, so our edge table will be 13 columns. If there have 13 edges, so in our edge table should have 13 columns. If there have 20 edges, so you have to mention into the edge table that is 20 columns. So you can see there is the table of ages and weighted. So age, every time we have to write here what is the age. A to B, AB is the age, and weight will be 4, just like that. Okay.